So we have carbon monoxide, we have mass, we have molar mass, we can now find moles. We want to find mass of iron. What is the molar mass of iron? 55.85 grams per mole. So now you can solve for your unknown because you can find moles, therefore you can find the moles of this, and now you only have one unknown piece of information. This is a typical gravimetric, stoichiometry kind of question you're going to see in university. You'll be given information about substance A. You will have to find substance B. So, formulas first. Moles of carbon monoxide is going to be 19.29 grams divided by 28.01 grams per mole. And if you notice, underneath my balanced chemical equation, I listed underneath that substance the mass and the molar mass. My unknown quantity is identified, and that molar mass. What is the formula? Mass divided by molar mass. So if you set it up like this, it helps you get started. So, somebody with a calculator, what's 19.29 divided by 28.01? On?
0.688681.
0.688.
688.
Can somebody verify that, please?
Yes.
Yep, okay. So we've got 0.45. Is there anything after that 9? Okay. You can't round off yet because this isn't our final answer. So does anybody else have 0.45912? Okay. Moles of Fe. Now we've got moles of iron. We can now find the mass of iron. So, if moles is equal to mass divided by molar mass, mass must be equal to moles times molar mass. So 0.45921 moles of Fe times 55.85 grams per mole. Equals? Braden?
I got a 25.64.
So it should be just less than half of 56. So it should be a little bit less. Your
I
mom?
have a question. So when we're putting like formulas like that, do you want us also to include the units? Or
Absolutely.
just the units?
It's with a unit, always. Looking for mass of iron. So we're looking for grams of Fe as our final unit. So we're going to start with something that has that unit in it. So you're going to start with the molar mass of iron. We need to get rid of moles of Fe. There's nothing in the given quantities with moles in it. So you have to use,
1 mole over 6.02 times 10 to the 23.
no, we don't need Avogadro's number of particles.
Oh, grams per mole.
Nope. What are we going to use? Mole ratio. There's 2 moles of iron for every 3 moles of CO2. So this is gone. Now I need to get rid of moles of CO2. What contains moles of CO2? It is up there. Alex.
Would it be the 28.01 grams per mole of CO2?
It would be the molar mass of, oops, sorry, that should be CO. Okay, so now moles of CO are gone. We've got grams of CO. One last quantity.
19.29 grams of
Gone. So in your calculator, you would put 55.85 times 2 times 19.29 divided by 3 divided by 28.01.
$25.64
25.64 grams of Fe. We haven't made any significant digits mistakes. We haven't rounded too early. We haven't dropped any of our units in our intermediate calculations, which some of you did on your assignments. And you get the same answer. Divided by the molar mass we've got moles of CO2. We want moles of lithium hydroxide. So you're going to multiply this by the mole ratio. So CO2 goes on the bottom because that's what we have already. So you put in your coefficients from your balanced chemical equation. So therefore, we need twice as many moles of lithium hydroxide. Right? Now, we have moles of lithium hydroxide. We can calculate mass. So if you take your answer, you multiply it by the molar mass so we're going to use the molar mass of lithium hydroxide first. When I set up my dimensional analysis here, it's 23.95 grams per mole. I put LiOH as well, so that I know what comes next in my mole ratio. Carbon dioxide goes on the bottom. Because that's the information that we have. I want to get rid of moles of CO2, so we're going to use the molar mass. Now I've got grams of CO2, so get rid of that. We have that. So in your calculator, you would be putting in 23.95 times 2 times 1 times 10 to the 3 divided by 44.01. I hope you understand I'm not putting the divide by 1 down. You don't actually do anything with that, right? It's not going to change your answer. And you will get 1,088 and change grams of lithium hydroxide. Okay. So always set up your question to start with by putting in the information that we know. So, what are we trying to find out? We want to find the molecules of chlorine, so that's an N. To find big N, what else do you need to know? We don't need to know the molar mass. We need Avogadro's number. What are the particles for chlorine gas? So, we will need to find the moles in order to find the number of particles. We don't have that information, but we do have a balanced chemical equation, and we have the mass and molar mass of substance A. So, we start there. We have 50 grams of disulfur dichloride. So now we can find the moles. Read them. 035? 315, thank you. So we've got the moles of disulfur dichloride. We don't want that though, we want chlorine gas. So you're going to multiply this by the mole ratio, what we have on the bottom, what we want on the top, and it's a 1-to-1 ratio. So we have 0.370315 moles of chlorine. And yes, you have to show it. You either put a statement in since a 1-to-1 ratio, or you show your mole ratio. So now we've got the moles of chlorine. We can plug that into our formula. And that will give us the number of molecules. Cl2. So this was 50 grams. Okay, so if I'm gonna, we want to find the molecules of Cl2. So you start with Avogadro's number because that quantity has the units that we want in our final answer, and they're on top. So now we want to get rid of moles. So Cl2 goes on top. S2. Cl2 goes on the bottom. I always set up my mole ratios like this. I put what I want on the top and what I want on the bottom. Then I go back and put the coefficients in. So we don't have moles of Cl2 anymore. 1 mole of S2Cl2 from our molar mass. $50 grams. So now grams of S2Cl2. So the only unit we're left with is molecules of Cl2. So in your calculator now, you would just put in 6.02 times 10 to the 23rd times 50 divided by 135.02.